Okay, class. Okay, we start. Okay, so we follow the timetable. After we follow the timetable, I think I'll be giving you extra class also on Saturday. Okay, we need to have one extra class every week. And we see how it goes about, then so that we can cover the syllabus. Is it fine? I'll discuss in the group later. I plan to have on Saturday around 10:30 to 12. Do any other subjects having extra classes on that day, Saturday, 10:30 to 12?
No.
No. Okay. I plan to have one every Saturdays. See how it goes. Okay. I'll put it in the group later. Okay. So capacitance. Okay. So electric. Do you heard of capacitor before? Yeah, I think in SPM you learn about capacitor, right? I think O level I'm not sure, but A level Form 5 SPM I think you learn about capacitor. Okay, what is the function of capacitor? Anyone?
Store charge.
So it's store. Yes, very good. It's to store charge. Capacitor store charge. Okay, and yeah, the main function is storing charge. So this is how it looks like. All the electronic circuits have a cylindrical shape, like this, cylindrical shape, very small size. If you open up electronic board, your motherboard maybe for the computer, you see like this. These are capacitors. So capacitor is store charge. Okay, store charge and release charge when it's necessary. Okay, because TNB supplies us what type of energy? Electric, AC or DC? TNB gives us alternating current. Alternating current, the current voltage will fluctuate up and down. So capacitor can store and release the charge so that the voltage across the device does not drop a lot to become like a constant capacitor. Okay, so this is the symbol, of course. This is those who knew for capacitor. I think this is the symbol. It's like battery. Battery also like that, right? Battery like that, but one long, one short for a battery, positive and negative. But for capacitor, both terminals are same length because both side can exchange their polarity. Not only left like positive, right also can be positive and left is negative. Okay, depend how you charge it. Okay. So you see this circuit here. This is a circuit of a speaker, amplifier actually. Those who know this symbol, this is what? This two? This is transistor, right? Transistor. You will learn more about transistor later. Amplifying the signal. So we have a capacitors here. Too many capacitors kept here. Okay. Okay, here the capacitor function in this circuit is totally different. Capacitor allow which type of current pass through it? Capacitor allows direct current to pass through it or alternating current to pass through it? Capacitor. Capacitor blocks which current? Capacitor blocks direct current. Capacitor blocks direct current, but it allows alternating current to pass through it. So in this circuit, let's say the input is here going to be some sort of a microphone. We have a microphone here. So microphone, the sound is changed to electrical signal. Okay, the electrical signal produced by the sound is alternating signal. It's alternating signal because sound up and positive and negative voltage. That alternating signal will pass through the capacitor and amplified and will be produced in the loudspeaker. Okay, but the loudspeaker will have its own power supply. There is a power supply here for the loudspeaker. The power supply used by the loudspeaker normally is a direct current, direct voltage. So the direct voltage, we don't want that current to passes through this capacitor and reaching the microphone. Okay, so here capacitor works as a safety. Okay, allow the alternating current from the microphone to pass through the amplifier to be amplified and block the direct current from the from the loudspeaker to reach the microphone. We don't want the direct current from speaker to reach the microphone. Okay, because normally loudspeaker is connected to a high voltage source. Microphone be producing a small voltage signal. So alternating signal can pass through the capacitor from the source of the speaker, blocked by the capacitor from reaching us. Okay. So in this case, capacitor works as a what you call safety feature, allowing alternating current, but at the same time blocking the direct current from reaching the microphone. Okay, so it's a device that can store charge. In A levels, I think it's proper to say store energy. Okay, it more to say store energy. There is two questions sometimes. There is one year they asked in A levels, why you can't say capacitor store charge? Why you can't say capacitor as store charge? Store energy makes sense, but not store charge. Why? Because they said if one plate charged positive, the other plate will be charged negative. If the positive is positive 5 coulomb and negative charge is negative 5 coulomb, the net charge stored in the capacitor is how much? Is 0. Okay, is 0. The net charge it has is 0. So we never said, it's not proper to say that capacitor store charge. Okay, we said capacitor store energy. Okay. So, but in A level, normally, let's say a student explaining and saying capacitor is storing charge and everything, they never penalize you. They never penalize you. But a proper way is capacitor stores energy. It consists of two plates separated by an insulator. Yes, the capacitor has a two parallel plate, like electric field parallel plate. In between, got some insulator. The insulator could be air, can be oil, can be mica, and so on. Have to be an insulator. Okay. Theoretically, scientists found that if you place an insulator between the plate, it seems capability to store charge by the capacitor increases. Okay, why? That is not in your syllabus. You can study why the insulator increases the capacitance of the capacitor. Say capability to store charge increases, and there is an insulator in between the plates. Okay, okay, but in your syllabus, the one we're going to discuss is the two parallel plate with a vacuum in between. Okay, it's going to be vacuum. Your syllabus is only vacuum. Okay. Okay, so this diagram tells charging capacitor. So, of course, the shape is like cylindrical. You can think like inside there is one parallel plate. There's one parallel plate. Okay, parallel plate inside. And if you close the switch, it will be charged. Okay, it will be charged. Okay. So like this. See the first diagram. Charging, fully charged and discharged. Let's first we see the charging one. Okay. When the switch is connected, the electron move from the negative terminal. Where's the negative terminal? Negative terminal is at the back. Negative terminal, the electron move back. The electron move back from negative terminal and makes the left hand what you call plate become negatively charged. Electron moves from a negative terminal of the cell to one plate of the capacitor, from the other plate to the positive terminal of the cell. So the electron here will accumulate here at this side. This electron won't jump to the other plate. This electron will push the electron of the right plate. The right plate, there is electron. The electron will be pushed by the accumulation of the electron at the negative plate, on the left plate. So therefore, the electron here going to move backward. Okay, move backward to get into the battery. So creates what? Creates a positive polarity in the right plate. Again, how the capacitor is charged? The electron is pushed to the left plate according to this diagram. Left plate become negatively charged. The electrostatic force between the charges causes the electron in the right plate to be pushed to the away from the capacitor. So therefore, create a positive polarity on the right plate. So create causes the capacitor to start to charge, okay, charge or store energy. Okay, so remember, you check the polarity. Let me go to the whiteboard just for a while. Okay, so if this is a capacitor and you have a battery, okay. So, oh, sorry, let me follow the diagram just now. I don't want to be confused there. Okay, so let me change the polarity. Okay, so the battery is like this. Okay, when the electron move this way, this is going to be negatively charged. Okay, and this is going to be positively charged. Okay, so imagine this capacitor is turning like a battery. It become another battery, turning battery. Store charge, store energy, it tend to become a battery. Okay, so let's say this is 6 volt. This is 6 volt. The battery is 6 volt. The voltage of the capacitor will start to rise. The voltage of the capacitor, the voltage, the V versus the time for the capacitor. This for the cross the capacitor. The voltage will start from 0. At the beginning will be 0 because no charge go through yet. But when the time runs, the voltage of the capacitor will rises until it will rise exponentially. It will rise exponentially. Then until the voltage finally achieve how much? 6 volt. Same as the battery. The battery 6 volt, the capacitor will eventually achieve 6 volt. Once the capacitor achieve eventually 6 volt, recall back your Kirchhoff second law links here. What Kirchhoff second law said? The total EMF equals to the total potential drop, right? Okay. So this 6 volt, this becomes 6 volt. What happened to the total EMF in this circuit? 6 volt, 6 volt. The total EMF of the circuit, according to Kirchhoff's second law, is 6 plus 6 or 6 minus 6. Anyone? When the capacitor charged 6 volt. Now the capacitor is already charged 6 volt. It's like a battery already. 6 volt, 6 volt. So the total EMF of the circuit, is it 6 plus 6 or 6 minus 6? How to know plus or minus? Check the polarity lah. You see here negative, here positive. So here the capacitor positive terminal is connected to the positive terminal. That means the capacitor wants the current to flow the same direction as the battery. Battery wants the current flow in which direction? In the clockwise direction. Okay, sorry, current. This is not a electron. The battery wants the current to flow which direction? This direction, right? Positive to negative. You want the current to flow this way, anti-clockwise direction. Anti-clockwise direction. The battery wants the current to flow anti-clockwise direction. Well, you see the capacitor. The capacitor, the positive is on the right. The capacitor has a intention to make the current to flow in which direction? To the clockwise direction. So the both voltage are opposing each other. So the total EMF will be not 6 plus 6. It's going to be 6 minus 6. So the total EMF of the circuit become 0 volt. This is the total EMF of the circuit. Total EMF of the circuit becomes 0 volt when the capacitor is completely charged. So during this, what happened to the current flow in the circuit? Current flow will drop or rise? Total EMF is 0. When the total EMF 0, current become, anyone? Current going to become 0. Okay. So when a capacitor is charged, the voltage across the capacitor will rise, but the current across the capacitor will, anyone? The current across the capacitor will drop. Okay, will drop. Why the current is dropping? Because the reason is, this is the reason. The total EMF is decreasing. That means, in other words, we can say that the battery feed someone who going to oppose the the person who created it. Okay, so capacitor always oppose the battery, although the battery is charging it. Okay, so this is a charging mechanism of capacitor. Okay, so the electron move from the negative terminal of the cell to one plate of the capacitor and from the other plate of the capacitor. When fully charged, the voltage of the capacitor is equals to EMF of the cell. So no current flow in the circuit when fully charged. Once the capacitor is fully charged, you can take out the capacitor. It's acting as a battery now. It's acting as a battery. Okay, that capacitor you go and connect with the light bulb. Okay, the capacitor going to release the charge and make the light bulb to light bulb. But the problem is the amount of charge stored in the capacitor is quite small, not that much. So don't expect the light bulb to light up for maybe 4 hours. It's going to give maybe a flashlight for a few seconds. That's it. After that, it will stop. What do you call light up? Okay. So capacitor, although it store charge, it doesn't carry lots of charges. Not like battery. Battery chemically made, so it can release lots of charge. Capacitor just temporarily store charge, but the amount of charge is stored is small relative to a battery. Okay. So now the third diagram, discharging. Okay. So as I said, sorry. So just now you found that here positive, here negative. So capacitor will going to make here positive, here negative. So when you connect this switch, this is positive, this negative. So current will flow which way? Current will flow this way. Okay, current will flow in a clockwise way. This is where the current flow. So here, if you fix the light bulb will light up for a short while. But energy is retrieved from the capacitor. Any questions so far from this diagram? Capacitor. Okay, so let's move on. Okay, so you have to remember this mechanism of charging. This slide very important. This slide. Okay, see, when the capacitor is charging, electron flows from battery negative terminal. Yeah, from the negative terminal, the electron, the focus is to the electron. Electron flow from the negative terminal, okay, to plate A, so become negatively charged from the other plate. Okay, equal amount of positive and negative charge then accumulate at B and A respectively, which will result in existence of PD volt across the plate. This PD is counteractive. Remember, it's counteractive to the EMF of the battery. It opposes the EMF of the battery. When V reaches V0, V0 means is the voltage exactly same as the voltage of the battery. V0, no current flows. Remember, no current flows. So through the circuit, there is now accumulation of charge in the capacitor, either plate. During the discharging process, where the battery is disconnected, the reverse flow of electron occurs. So the electron flows this way, in which direction? Like anti-clockwise direction. When you connect the capacitor here now, capacitor here with the light bulb, so the electron will flow opposing the original direction. Opposing. Now we're going to release from here to here, the electron. Okay. So this is the charging and discharging graph. Charging. Okay, let's say this is the capacitor, this is the battery. Okay. Okay. This is your capacitor, this is your battery. So current flows this way. Okay, so current flows this way. So current going to drop. Current flow in this case, anti-clockwise direction. Let's say we assume positive. So current will drop. Current will drop until it becomes zero. When it reaches zero, we say the capacitor is charged. Okay, the capacitor is charged. Okay. When the capacitor discharging, you're going to release the current this way. Okay, you're going to release the current the other way because this is going to be a positive plate now. This is negative plate now. Go release the other way. So that's why current release is this way, negative direction. Okay, like this, and eventually going to zero when the capacitor is totally discharged. Okay. Okay, that's the diagram for the current. Now this diagram 2. Diagram 2, you see VC and VR. What is VC and VR? Okay, VC and VR. Okay, VC graph, the voltage goes up. VR graph, the voltage goes down. What is VR and what is VC? In reality, when you have a battery, okay, when charging a capacitor, we won't charge capacitor with a direct connection. We will have a resistor in the circuit. Okay, we will have a resistor in the circuit. Okay, so there will be a battery, there will be a capacitor. For the sake of the purpose of this circuit is want to charge the capacitor, but we need to have a resistor to charge a capacitor. Why? If you don't have resistor, what will happen? Anyone? Let's say like this circuit above here, this circuit. I draw without resistor. In reality, there should be a resistor. If I have the circuit above, only the battery directly connected to the capacitor. Can we charge the capacitor directly connected to the battery? What will happen without resistor? Anyone? Anyone? Why you can't charge a capacitor directly connected to a battery without a resistor in the circuit? What will happen? Anyone? So there is a battery. Battery, let's say voltage is 5 volt. You're going to charge a capacitor which don't have charge, 5 volt. You have never fix a resistor in this circuit. So what will happen if you don't fix a resistor? The capacitor will blow. The capacitor will blow. It's just immediately going to blow. Okay. Why? Because resistance in the circuit is about zero, no resistance. Therefore, the current in the circuit will be very high. So high current connected to a capacitor can blow the capacitor, can damage it. Okay, so that's why we need to have a resistor. What is the function of resistor here? To limit the current flow into the capacitor. Okay, so if the R is very high, the time taken to charge the capacitor become low. The time taken to charge a capacitor become low. Why? Why? Because the current flow in the circuit is very low. It takes time to charge the capacitor. Okay. If the resistance R is very low, the current will be huge. The capacitor can be charged very fast, but dangerously. You know, like your phone fast charging, fast charging, slow charging. Slow charging more safer, because the amount of current flow is small. Never damage your battery or the internal circuit of the battery of your phone. A fast charging charger, very dangerous because the resistance is very low. The current is so huge. Of course, it looks very convenient because it's charged faster, but at the same time, very dangerous. It can heat up, it can explode. Okay. Okay. So this is the graph section, all curve. Any questions from this graph? No questions, Okay. Charging, yes. Any questions?
No.
No questions, okay. Okay, the uses of capacitor. What is the use of capacitor? Of course, to store charge, high-speed use, such as camera flash. You know, camera flash, the flash comes out from the camera. When you press the button, the flash comes out. The flash comes out. The energy to the flash is supplied by a capacitor, a charged capacitor. The capacitor will instantly release all the charges so that the current will be very huge. So sudden burst in the intensity of the light will be very high, so you get flash. So flash energy for flash is retrieved from a capacitor actually, from a capacitor. So the function of capacitor is of course for a camera flash. Okay. Another important use of capacitor which you learn in SPM, smoother out DC voltage that has ripples. Okay. What does that means? Of course, as I said, TNB gives us AC. AC. Okay, let me go to the whiteboard. What is meant by second one? Okay. Okay. So yeah, this is your house. Okay, for the house, the electricity from TNB is in terms of AC. AC. So we use a transformer. We use a transformer to change AC to a lower voltage, smaller voltage. Maybe this is 230 volt. When come to you connect to your laptop in the house, you connect the power supply. So your adapter, your computer, your adapter contains a transformer, also another transformer, and as diode. Okay, it has a diode and transformer. Transformer reduce the voltage further down to the voltage of the laptop, maybe 9 volt or less than around 9 volt, I think. So 9 volt. Then the diode will change AC to DC. AC current will turn to be what? Will be a DC, direct current, like this, direct current. Laptop only works DC, based on DC. So TNB gives us AC, the diode change to DC. But this DC retrieve from diode, if you those who are SPM, it's going to be not a perfect straight line. It'll be what? It'll be like this. It'll be like a little ripple. So it'll be like a curve ripple. So what happened? We use a capacitor to smoothen it. In reality, it will be like this. It will be like this actually. The DC current will be like a ripple retrieved from AC. The below current will be chopped up. Only in the top will be there. So your current directly changing from AC to DC by using a diode. This AC current will turn to become rectified like this. Yeah. So this is DC current. But this is bad. This is not good. For a laptop, you're getting a current like this, going up, zero, going up, zero, going up, zero. The diode screen, I mean the laptop screen may be like a bright dimmer with a high rate. So that's not good. So what they do, they try to make this graph into a more flatter one, like this. Okay, you'll get like this, something like this, which is never really drop to zero. This done by a capacitor. Capacitor does this job, called smoothen. Smoothen what? Smoothen a DC voltage which has a ripple. DC voltage only have ripple if it retrieve from an AC source originally. Okay, so that's the second uses. Smoothen out DC voltage that has ripples. Okay, and the third one I already told you just now, the earlier picture, block DC voltage. Block DC voltage. Why we want to block DC voltage? Like someone want to sing by using a microphone connected to a speaker. Okay, microphone, you are producing alternating current. Alternating current must reach the amplifier and to the speaker later. But we don't want the power supply connected to the speaker, which is a direct current, to reach to your microphone. Then you will be electrocuted. So capacitor plays a role to block DC voltage from the speaker. So these are the three main uses for capacitor. Okay. So capacitor made of a parallel plate as a vacuum in between. They found that more charge you want to store on the plate, it depends to what voltage you supplied across the plate. What voltage you supplied across the plate. That determines how much of charge is stored. Okay. So this is the capacitor. You connect to a power supply of 6 volt. Okay, the charge, let's say 6 coulombs stored in the plate, let's say. You raise this voltage to 12 volt. Okay, the charge stored here will be like 12 coulombs. The amount of charge stored in the capacitor is depend to how much of voltage you supply to it, you connected to it. Okay, so that causes the creation of the first formula for capacitor. The amount of charge stored is proportional to the voltage applied across the plate. Okay, Q proportional to V. Okay, so therefore Q proportional to V, mathematically you make equal Q over V must be constant, right? Q over V is constant. This constant has a special name called capacitance. This is called capacitance. Okay, the device is named capacitor, but the capability to store charge is measured by using the term called capacitance. Okay, when you go to the shop, you see asking for capacitor. I want to buy a capacitor. They will ask for the rate. How much of capacitance of capacitor you want? You want 10, 20, there is a rating. Capacitance, what is meant by capacitance means, that's the definition. What is the meaning of capacitance? Capacitance is measures the charge storing ability. How much the capacitor can store. Bigger the capacitance means, the bigger the capability to store the charge. Okay, so capacitance is defined as, this is the important term to remember. What is capacitance? C is defined as the ratio of charge stored on either a plate, either one of the plate. Charge stored in one of the plate, you must say it one of the plate, to the potential difference between the plate is called capacitance. And C equals to Q over V. Okay, the unit is weird unit. We call it farad. Farad is a unit for capacitance. 1 farad means what? The C is 1 farad means, you can imagine that when you apply 1 volt across the capacitor, the amount of charge stored in the capacitor in each plate is 1 coulomb. Okay, 1 coulomb. 1 farad. 1 farad. Okay. So yeah. So this is the first important formula you learn. What is that? Capacitance. What is capacitance? The ratio of charge stored in one of the plate to the potential difference between the plate. Okay, that's capacitance. Okay, so yeah, the unit for farad, 1 farad, the unit is a very big unit. Okay, you know, Earth is a capacitor, is a natural capacitor. Our Earth is a capacitor. Okay, so Earth has own capacitance. Earth has its own capacity because Earth also store charge. When a cloud gets closer, yeah, of course, the Earth, if the charge, the Earth become positively charged. It's a huge charge storage, so it has a capacitance. Even Earth so big is a capacitor. The capacitance of the Earth capacitance not even 1 farad. Okay, not even 1 farad. Maybe some 800 microfarad. We're not mixing it. You can check from the net, but definitely not 1 farad. The capacitance of the capacitor of the Earth, the capacitance of the Earth, sorry, is not even 1 farad. Why I'm trying to tell you this is the unit farad is very big. Okay, therefore the capacitor connected in your motherboard, in all electronic devices will be in form of, the rating will be in microfarad or picofarad normally. Okay, so after this slide, all the capacitance value will be in microfarad or picofarad. Okay, because 1 farad we don't have one. It's very huge, so we got to use picofarad or microfarad. Okay, class. So one question for you to think about capacitor. Okay, look at this question. Let's try to visualize what happened. Okay, so you see the circuit here, 12 volt, 1 mega ohm, 22 microfarad. So now what is it? Diagram shows the capacitor connected in series with the resistor. Okay, micrometer switch, 12 volt battery. When the switch is first closed, what is the PD across the capacitor resistor will be? Okay, now anyone? First, 12 volt connected to the resistor and capacitor. Okay, use Kirchhoff's second law. Kirchhoff's second law says what? The total EMF of the circuit, which is 12 volt, is equals to total potential drop across the resistor. So here 12 volt, capacitor haven't charged yet. So how much of volt it uses? It uses
0.
0 volt. So the resistor is taking all the voltage. It takes 12 volt at the beginning. When the time is 0. When the time is 0, resistor take all the voltage, capacitor take 0 volt. Okay. So the PD, so that's the answer going to be the first one. Okay, the first one, the PD across the capacitor will be 0. Okay, because I haven't charged yet. So the resistors take 12 volt, you take all the 12 volt. So what is the current when the time 0 at the beginning? What is the current flow? So you can use B equals to IR for the resistor. V equals to IR. I equals to VOR. So V takes 12 volt. R is 1 times 10 to the power of 6. R, the resistance. So the current flow is 12 microampere. So when the time 0, the current flow in the circuit is 12 microampere. Current is 12 microampere. This 12 microampere is the largest, is the maximum or the minimum for the entire process of charging of the capacitor. The 12 microampere. Is it the maximum current ever going to flow or the minimum current ever going to flow in the charging process? It's going to be the maximum. The maximum 12 microampere. Then when the time runs, the current definitely going to drop to 0 when fully charged. When fully charged. At the time 0, the current is the maximum 12 microampere. Okay, so finally, the charge on each capacitor plate when the time 0 still not haven't charged yet, so definitely 0. Okay, I hope the part A is quite clear. So what I'm trying to emphasize here is when the time 0, the current flow is maximum, the voltage across the resistor is maximum, and the voltage across capacitor is 0. The charge stored in the capacitor is still 0. Okay, now check the part B. Part B. Part B, is it clear? Calculate the same quantity as A when the switch has been closed for some time, so that steady conditions have been reached. Okay, now after close, a steady condition have been reached means after it completely charged. Now it's completely charged. How this 4 readings going to be? When the capacitor is completely charged means capacitor already turned to become a battery, and it's going to make a how many volt? It's going to make a 12 volt, same like the power source who created it, but its polarity going to oppose the polarity of the battery. So it's going to act like a battery here, 12 volt, opposite direction. So first, the PD across the capacitor going to achieve what? 12 volt. It's going to be 12 volt, same like the battery. Okay. The battery feeds the capacitor. Capacitor grows, but it opposes the battery who feeds it. Okay. When it's completely fully charged, it's going to stop the current flow. It won't stop because total EMF is 0. The second, the PD across the resistor, of course, becomes 0. Resistor cannot take any PD anymore because 12 volt here slowly building up. Let's say this is not 12 volt. Let's say this is 2 volt. Middle of building up, middle of charging. Let's say this 2 volt, this 12 volt, this 2 volt. What is the resistance of voltage of the capacitor resistor will be at that moment? Will be 10 volt. Will be 10 volt. This 2 volt, this will be 10 volt. When this become 3 volt, the voltage across the resistor become 9 volt, like that. So finally, when the capacitor become 12 volt, the voltage across resistor becomes 0. It reaches 0. Yeah. C, definitely the current going to drop to 0. No current anymore because total EMF is 0. So then D, what is the charge on each capacitor plates? So the new formula you learn here now. Q equals to CV. Actually, the formula is what? C equals to QOV. So you want to find what is the total charge stored? Is C times V. The capacitance of the capacitor times the voltage across the capacitor determines how much of charge is stored. So C is 22.10, 22 times 10 power negative 6 micro, and V is 12. So you get 264 microcoulomb. Is the amount of charge stored in the capacitor. Okay. So yeah, any questions from this slide? Okay, so stop me if you have any questions. Okay. Okay. Now, your turn. What is the answer for this example? Capacitance equals to Q over V. Yes. The formula. A capacitor of capacitance 10 microfarad. A capacitor of capacitance 10 microfarad is connected to a battery of 12 volt. What is the charge on its plates? So C equals to QOV. So yeah, so capacitance is 10 microfarad. Please change the micro to farad, 10 power negative 6. Then you can find the charge in coulomb. Okay, so use this formula for the A, you should be able to get the answer. Okay, direct substitution. Okay, calculate for me the B2 before I show you the answer. The answer is there. For the case of B, what potential difference must be applied between the plate? For 100 microfarad capacitor, for a charge on them to be 0.025 and negative 0.025. So same formula. So C equals to Q over V. You want to find the V should be Q over C. But the problem here is now, what charge you substitute in the formula? 0.025 only. Don't add them. Don't add them. This charge above is charge stored in one plate, in one of the plate, one plate. So 0.025. No need to put a negative also, just the magnitude. So you get the voltage.
What about for A? Like you found the charge and then what sign? Do you have to include the sign, whether it's positive or negative or both?
Okay, the charge you get for the first one, let's say you got 5 coulomb, let's say you got 5 coulomb. So you must understand that positive plate is positive 5 coulomb, the negative plate is negative 5 coulomb. That's it. So you don't need to put the sign. You cannot put the sign.
Oh, so you just put 5.
Just 5.
Okay.
But you must visualize like this one, right?
Okay.
Positive 5, negative 5. Okay, so yeah, so this is the working. I think you get that working. It's a direct substitution, right? The 250 volt requirement, and the charge is 1.2 times 10 to the power negative 4. I don't need to put positive, negative, just leave it as a magnitude. Okay. Okay. So this, and the voltage is keep on rising 600 millivolt to 12 volt. Different capacitance of capacitor, the amount of charge stored varies. Okay. So you have a capacitance of 2.2 microfarad and you apply 12 volt, the amount of charge stored in the capacitance is 26 microcoulomb. So you might think, why we need to have a variety of capacitance? Because even 10 picofarad, can it store 26 microcoulomb of charge? Can it store 26 microcoulomb of charge? You can. How do you do that? You raise the voltage, right? You can raise the voltage to store more charge. But in reality, it's dangerous. You can't give high voltage to a particular capacitor. The capacitor, when you buy a capacitor, at the labeling itself, they write you the safety voltage. Maybe they put 12 volt safety voltage. If they put there written there 12 volt, of course they write the capacitance also, and they write the capacitance maybe 200 microfarad. Okay, volt, don't 12 volt. If you apply more than 12 volt, what will happen to the capacitor? The capacitor will
No.
or the plate. You see the plate here, and you have what you call, okay. So let's say suppose you give 12 volt, but you were giving 13 volt. What happened? The amount of charge stored on the capacitor on the plates will be more than the means. What will happen? Electrical breakdown will happen. We call it electrical breakdown. The positive charge will start to flow. Sorry, not the positive charge. The negative charge flow through the vacuum inside the capacitor. Okay, okay. This mechanism, same thing like the Earth and the cloud. You know, the Earth and the cloud get closer, it create a negative charge at the cloud and positive charge at the surface of the Earth. It's a big capacitor. It's electric field. It's a capacitor. So when get closer, lightning happens. We call electrical breakdown. Same thing will happen in the capacitor. Okay, so you can't give voltage beyond the voltage stated on the capacitor. In exam, they do ask what will happen. So you see, like, okay, more than 12 volt. Okay, so your turn now. Look at the circuit. A large capacitor is shown as used as shown above in the camera flash unit. Calculate the charge it stores, and the control system connects the capacitor directly to 30 volt power supply. So the charge stored when the control system directly to 30 volt power supply. So now the capacitor is connected. The charge is stored when the control system connects the capacitor directly to 30. So what you have to say? You have to say 3 marks question. You have to explain from where to where the electron is flowing. Okay, then you have to tell which plate turned to become negative. Then you have to say when the capacitor of the capacitor, the voltage of the capacitor equal to the voltage of the battery, current stop flowing, the capacitor is completely charged. You know the description earlier I show you, this description. So you have to explain this mechanism. Okay, and the capacitor is charging, electron flows from what to what, and which plate become positive, result in existence PD of voltage. So when the V reaches V0, current becomes 0, capacitor is completely charged. Okay, so that's the answer you're supposed to explain this question, the first question. Okay. So the charge is stored when the control system is connected to the capacitor directly to 30 volt power supply. Or they want the charge, sorry. How are they charging? The charge source is CV, C times V. So you got 14 column. Okay. So next, capacitor is charged later. When you press the camera button, the circuit will directly connect it to the capacitor. When connected to the capacitor, so a huge current will flow into the capacitor. So you get the flash. Flash cannot connect directly to the battery. 30 volt connected to the flash, the current flow is not as big as the current comes out from the capacitor. Capacitor straight away connected to the flashlight, the current is very huge. That's why we never connected the battery to the flashlight. Flashlight, the energy need to be stored in the capacitor, and just one in a few short time, all the charges of the capacitor will be released, result in a big current. So bright light will appear. So the average discharge current is the control system connects the capacitor discharges tube. It discharges in 0.2 millisecond. What is the average current flow? So yeah, the Q total charge stored is 14 coulombs. So it releases it in 0.2 millisecond. So Q over T will give you the current, 70 kilo ampere of current passed by the flash, but in a short period of time, only 0.2 millisecond the flash lasts. But you must understand why they said they said average current. Average current. Why they said average current? In reality, the current flow in the flashlight is what? I versus T It's actually going down. It's going down like this. It's reducing like this. But they're asking for average current. This is your average current. So we do QOT. Total charge divided by the total time. We get the average current. Okay. Okay. So yeah, that's today's lesson. This is next part. Parallel series. Any questions today's lesson? So today's lesson, what do you learn about capacitor? So capacitor is a device for energy. Okay, you must know why we can't say store charge, because each plate has same amount of magnitude of charge but different sign. Therefore, total charge, net charge stored is 0. Okay. Okay. Next, you have to know that the C equals to Q over V. Capacitance. Define capacitance. What is capacitance? Is the amount of the ratio of charge stored per unit volt between the plate. Okay, the amount of charge stored in one plate. You must say that the amount of charge stored in one plate over the potential difference across the plate. Okay, so capacitor blocks which current, allows which current? Capacitor blocks direct current by charging itself, but it allows alternating current. Alternating current can make the bypass the capacitor. Okay, the next class, please try to recall. Let's say you have alternating current with the capacitor here and put a light bulb, and direct current with the capacitor here with a light bulb, 1 and 2. Which will light up? 1 will light up or 2 will light up? This is AC, alternating current. This is DC, of course. AC will light up or DC will light up? AC will light up. Okay, AC, the light bulb will light up because current will flow here this way, charging the capacitor. Current will flow, but after half cycle, the current will flow this way. Light will light up. The light bulb still getting the current, but capacitor will be discharged. So charged, discharge, charged, discharge, but the current successfully passes the light bulb. Light bulb will continually light up. But direct current, and the current flow a few milliseconds, when the capacitor is fully charged, the light bulb stop light up. Okay, so won't work. Okay, so any questions?
Sir,
Yeah.
what is the time for Saturday lesson?
I plan from 10:30 to 12.
10:30.
Uh,
Okay. Thank you, sir.
no problem. So I need to give one extra class every week. Okay, we will discuss. We put it in the WhatsApp. You any concerns, you just send to me. Let's think about it. Okay. Okay, guys. So I stop here. If you don't have question, I stop here.
All right. Thank you, sir.
Okay, good attendance today.